Hey, good morning, everybody, and welcome to our pre-calculus 40S class. And thank you for joining us today. So, yesterday we started doing the review, and today what we're gonna do is we're just gonna continue on going over the solutions for the review. So yesterday we went from question 1 to question 5. So I'm just gonna start off with question number 6 onwards, and then we'll try to go as far as we can with this. So I'll just do all of my solutions on a separate sheet of paper, just because sometimes I don't have enough room, and yeah. So let's go here. At some point, and if you have any questions, let me know, and then I could help you out with, you know, help you clarify things. So this is on page 446, and we're doing the review questions. Okay. And I'm glad that we're doing this right now because our test is on for tomorrow. So question number 6 says solve the equation. Solve the equation 1.04 to the exponent 2x equals to 2. So what we're trying to find out is what is this x value here, that if we go 1.04 to the exponent 2 times this number will give me exactly 2. I don't know if that's just an exact value. Most likely not, but it says on the book, give our answer in the nearest tenth. So state answer in nearest tenth. Okay, so I'm already thinking that it's not a really nice whole number answer. So how do we go about with this one? What we're going to do is we're going to take the logarithm of each side of the equation. So take the logarithm of each side of equation. So 1.04 2x equals to log of 2. Okay, now because we're doing logarithm, we understood that the base there that we're operating on is base 10, and that's okay. So from here, what we're going to do is we're going to apply the logarithm rules, where the exponent here, 2x, uh, will be at the front, multiplied with the logarithm of 1.04. So to use logarithm rules, times log of 1.04 equals to log of 2. Now, log of 1.04 is just a number, and log of 2 is just a number. So we're trying to solve for x. So to do that, isolate the x, so divide that both sides of the equation by 2 times log of 1.04. If I do it in that side, I gotta do it on this side as well. Like that. And then you know that the 2 would cancel. The log of 1.04 will cancel that one. And then we're left with just the x. We're just left with the x. Now, when I'm ready to do this on a calculator, sorry, I want to make sure that I tell the calculator that I want the log of 2 be divided by all of these things. So I might have to use some brackets, another brackets to group 2 times log of 104. Okay, so let's give that one a try together. If you're watching it right now, you can try it and see if we get the same answer. So log of 2. And I'm going to tell my calculator that I'm dividing by all of these denominators. So divided by brackets, 2 times log of 1.04. And then press equals. So that I get an answer of 8.83649. So it's just a long string of number, but then they said state it in one decimal place nearest tenth. So if we were to round it off, this is approximately equal to 8.8. Okay, so what's that saying is that this number is approximately 8.8. So if we check our answer, if we checked our answer, it's going to be 1.04 to the exponent of, okay, I'm going to put the brackets, 2 times 8.8. And I might not get an exactly 2, but it's going to be very close to 2. Very close to 2. Yeah, it's 1.99. So the reason why we didn't get exactly 2, it's because we only kept one decimal place. So that's question number 6. So let's go on to question number 7. Number 7 looks like it's a word problem. So let's take a look at this one here. Question 7 and 8 are word problems. I'll read it out first. A new combine used for harvesting wheat is $370,000. Its value depreciates by 10% each year. The value of the combine, V, thousands of dollars after T years, can be modeled by this function. So V is the value equals to 370. Now, because instead of writing down 370,000, the V is already in thousands of dollars. So they just put 370. And now you're probably thinking, well, what just happened in here? They said depreciates by 10%, and then I don't see any 10% in here. So I'll explain that for a second. Now, the word depreciate means a loss of value. So this new combine after a year is not going to be worth $370,000 anymore. It will lose its value because it's getting older, it's getting used, right? And some parts are falling apart. So it depreciates, it loses its value by 10% each year. So if it lost 10% each year, then that means so 10% loss of value each year. So if it lost 10%, how much remains? Started off with 100% minus 10%, which was lost. Now we're left with the 90% value left over. And that's why when we see our equation, it looks like this. That's why V is the value is equals to 370, and 370 is in hundreds of thousands, thousands of dollars times 0.9 T. So this 0.9 came from the 90%. Okay, so that explains that formula there. So letter A, it says, what is the value of the combine when it's 5 years old? So we're looking for the V. What is the value of the combine when it's 5 years old? So 5 years old, they're giving us T for time. So V is equals to 370 times 0.9 to the exponent 5. And then this one here, I mean, that's pretty straightforward. We just calculate that piece. 370 times 0.9 to the exponent 5. Okay, so now the combine is 218,481. So 218.4813. Now that doesn't mean it's $218 because this is in thousands. So timesing it thousands of dollars after. So timesing it by thousand, so V is equals to $21,848.13. Oh, so 218 rather. Where's my 218,000? Because it's timesing it by thousand, so timesing by thousand, so 218,800, $481. Okay, so that's that one. Now let's take a look at letter B. When will the combine? The question is, when will the combine be worth 100,000? So when is the combine, this big machine for farming, when does the combine reach be worth 100,000? So they're telling us the value, and then we're looking for answering the when question. So we're looking for time. So going at our formula, 370,000. So the value is 100,000. We're going to put that over here. And equals to 370 times 0.9 t. Now what we can do is, if we want, we can divide each side already by by 370. Oh, actually here, because it's already in hundreds of thousands, I don't have to write down 100,000 in here. So I'm just going to write down 100 because the value is in hundreds, 100,000, number of thousands. So divide both sides by 370. So that cancels, that cancels. Now this is going to give us a value. Now let's see what that number is. 100 divided by 370 is going to be 0.27, 0.27. I'm just going to just leave it like that for now so that later I don't have to round off right away. So it's 100 divided by 370 is equals to 0.9 times t. Oh, 0.9 to the t, exponent t. So since the question that we're looking for is the time, and the time is in the exponent, now we have to do the logarithm, right? Because the logarithm solves for the exponents. So I'm going to take the logarithm of each side of the equation. And if I go here, log of 0.9 t. And I'm going to use that logarithm rules. So I'm going to take this exponent t and bring it to the front. So this one still says log of 100 divided by 370. And then that's going to be t times log of 0.9. Okay, there, we're almost done. The only thing that we have to do to isolate the t, now that the t is down here, is to divide both sides by logarithm of 0.9. So divide by logarithm of 0.9. If I do it on one side, I gotta do it on the other side. That's what equation does. So dividing, that cancels each other out. So since those two cancel, we're left with t. So t is equals to log of 100 divided by 370 divided by log of 0.9. And then these ones, oops, you can't see that, sorry. And these ones is just a whole, it's just a number. So make sure that we take the logarithm of 100 divided by 370. You might have to put a brackets there. So let's go ahead and type that in. And if you're watching it right now or you're watching it later. So log of 100 divided by 370. Okay, so now I got an answer. It says 12.4. Did I say how many decimals? Give the answer to the nearest half a year. So decimal, one decimal place. So that's approximately 12.5 years, 12 and a half years. Okay, so it takes about 12 and a half years or 12.4 years for the combine for this machinery to be worth 100,000. Okay. If, I'm gonna post all of these online, so if you're not sure, if you didn't have enough time to copy it down, you can listen, you can jot things down, and then we can work it out again later. So now let's take a look at question number 8. So now we are at question number 8. I'm just going to show you the question that I'm working on. So it says here, a principal of 2,500 is invested at 3% annual interest compounded semi-annually to the nearest year. How long will it be until the amount is 3,000? They didn't give us the formula in here, but the formula is actually on our notes. So this is the compound interest formula. Okay, so it didn't have the formula. So let's write down the formula down in our solution. This is number 8. So the compound formula compound interest. A is equals to P times 1 plus R over N to the NT. And you can take a look at the notes that we have on lesson 8 for this kind of formula and what does the N represent, what does the T represent, what does the P, and what does the R represent. So, so it says here, the principal is 2,500. So on your question, it says 2,500. That's a principal. 1 is just 1. And then R is the rate of interest. It's 3%. So to be able to use this on a formula, we have to divide by 100. So 0.03 divided by N. N is a number of compounding times per year. Now the compounded times is semi-annually. So it says semi-annually. So that means N is equals to 2 times a year. So 2. So 2 goes in there. And then, how long will it take? We're actually looking for time. for this amount to become 3,000. So the A is 3,000. So they're telling us a story here. This is what we put in, and if we leave it so many years, the amount of years, the 2,500 will grow interest and it will become 3,000. So we're looking for how long will that take. So as you can see here, the exponent that we're looking at is the t, and yeah, because it's the exponent that we're looking for, we have to do a logarithm in here. So first of all, let's divide both sides by 2,500. So that just kind of eliminates that one. So 3,000 divided by 2,500. We're going to get, oh, that's a nice number, 1.2. 1.2 is equals to, now we're left with this one. Let's see if we could, this is a nice number. I think it is. So 1 plus 0.03 divided by 2, and it's a nice number, 1.015. So we'll just 1.015. So we don't have to type in all of that. So that's a nice way of simplifying all of that. Now apply the logarithm rule. So take the logarithm of each side of the equation. So log of 1.2, log of 1.015 to the exponent 2t. Okay, now that we've put in the logarithm of both sides, we take this 2t to the front, right? Apply the logarithm rule. So logarithm of 1.2 is equals to 2 times t log of 1.015. Okay. Now that we have that, okay, so we've taken the 2t, bring it to the front. Now the t is here. We can now divide both sides by 2 times log of 1.015. So divide both sides by 2 times log of 1.015, 2 times log of 1.015. And that just cancels the 2. That cancels the logarithm of 1.015. And then we're left with just the t. Now, when we get to this part in here, I want to make sure that I enter this on a calculator correctly, because I want the logarithm of 1.2 to be divided by all of these. So I must put brackets there. To tell the calculator, I'm dividing it by all of that. So let's go ahead and type it in. Okay, so now it looks like it's approximately 6 years. Okay, so they said to the nearest, calculate to the nearest year. So it's approximately 6 years. Okay, so if we start with 2,500 and it grows 3% semi-annually, and if we kept it for 6 years, after that, after 6 years, it will be worth $3,000. Okay, so that's a really nice one to do. Now let's take a look at question number 9. Okay, so if you have your book with you, you can have the book open and then we can look at this one together. It says here, question number 9a is to write each logarithm as an exponential function. Right from logarithm to exponential. Okay, so this is a nice a nice practice to change from logarithm to exponential, and then we're also going to do exponential to logarithm. So log base 3 of 729 equals to 6. So how can we write this as an exponential form? Exponential. Now this is your base. Okay, this is the base of the exponent, so that's going to be 3. And log tells us the exponent needed. Okay, so that's 6. And what's that equal to? What is that number? 729. Okay, so 3 to what exponent? So that's 6 equals to 6 is equals to 729. So that's 9a. And then we're going to go 9b. 9b. We're going to go logarithm of base 4 of 2 root 2 equals to 3/4. Okay, so what base are we doing for our exponent? Our exponent will have a base 4. What exponent do I need? 3/4. And what will that equal to? 2 root 2. Okay, so that's basically that one. So just changing it from logarithm form to exponential form. Okay, that's not too bad. Now, letter. Oh, so this is A still. This is still A. 9A. 9A1. 9A2. Okay, now we're going to go to B. B says write the exponential form to logarithm form. We're going to go the other way. Exponential form to log form. So how do we do that? Here's 1. 4 to the 5th equals to 1024. So logarithm just talks about log of what base? Well, we know it's base 4. Okay. Log of what number? So base 4. And then the exponent is 5, so 5. And the number is 1024. So it means that 4 log base 4 of 1024 is equal to 5. So the exponent 5 will be right there. Exponent, the base of the exponent would be right there. And then 1024 is there. Okay. Let's take a look at the next one. 5 to the negative 4 is equal to 1 over 625. Okay, so if you want to do the logarithm of that, base 5, log base 5 of 1,000, or sorry, not 1,000, 1 over 625 is equals to negative 4. Okay, because remember the logarithm is figuring out what is the exponent. So the exponent is negative 4. Okay, so I hope that's good. We are progressing really, really nicely. And let me see if there's anything. I might have to jump some, go over something that's going to be a lot more calculation. So I'll probably leave that with you, 9A and B. Number 10 is pretty straightforward, so I'm not going to do that one right now. That's probably looking at the exact value or looking at the benchmarks. We could do a change of base for that one too. So let's take a look at number 11. So we're going to jump to 11. It says here graph y equals to log of x base 6. Now, this is the logarithm graph. When we talk about logarithm graph, we said that the key points are 1, 0, and base 1. Okay, so in this particular case, there's no transformation involved. I can see it's just log base 6 of x. So that's our point. Xy would be 1, 0, and then 6, 1. So if you were to graph that thing, 1, 0, that would be right here, and then 6, 1, 2, 3, 4, 5, 6, 1. Okay, and just remember what the graph of logarithm looks like. So it kind of looks like this. Okay, so the question says, like, you could actually see what the intercepts are. So you can see the intercepts are, this is A intercepts. The x-intercept is equal to 1, and in y-intercept, there's none. Okay, so I just want to kind of touch base with this one in here. How do I know it's 1 and none for y-intercept if we don't have a graph? So is there a way to figure out the x-intercept and y-intercept without the graph? So to determine x-intercept, we're going to set y equals to 0. So y equals to 0, log of base 6 of x. Okay, so how do we solve for this one? So we already have the exponent for base 6, so we can rewrite that as exponent form. So 6 to the 0 equals to x. Okay, and what's 6 to the 0? 6 to the 0 is 1. So x-intercept is 1. Okay, so that's, I mean, even if we didn't have this graph, we can calculate it. Now, what about the other one? To determine the y-intercept, we're going to set x equals to 0. X equals to 0. So it's going to be y equals to log of 6 of 0. So now let's ask ourselves in here, log base 6 of 0 is what? So ask ourselves, what exponent do I need to apply to 6? What exponent do I apply to 6 to make it 0? So you can't think of anything that will make 6 to something will give us 0. There is no solution here. No solution, because there is no exponent that will give 6 to the something will give you 0. Okay, nothing. So no solution, therefore no y-intercept. And that's why it says there none. Okay, so that answers that. So even if we didn't have the graph, we can still figure out what the intercepts are. How could you use the graph of y to graph y equals to 6x? number letter C. Now, if we know that the graph of si- log of 6 base x is like this, 4, 5, 6, 1. So these are the key points. How can we graph the y equals to 6x? Now, because log and exponential functions, log function, are inverse of each other. So because they're inverse of each other, when we talk about inverse function, we said that the domain of the function will be the range of the inverse. So this one would go like this, and then this is, instead of 1, 0, it's going to be 0, 1, and instead of 6, 1, it's going to be 1, 6. So it's going to look like this one. This is the y equals to x line of symmetry. This graph is y equals to the 6x, and then this graph would be the y equals to log of base 6 of x. Okay, they are inverse of each other. They're symmetrical about the y equals x line. Okay, so that's that. That's really good. Good review of inverses. Now we're going to go to number 12. And number 12, there's quite a bit of stuff in here. I'm going to do number 12. I'll probably just do 12A, and then we'll go on. Yeah, I'll do 12A and maybe 12B. 3 log of x equals to 1. No, 3 log of x plus 1/2 log y minus 2 log z. And we're supposed to write that as a single logarithm. So how can we write that as a single logarithm? They're all 3 separate terms. So what we're going to do is we're going to apply the laws of logarithm. So it says here 3 times log of x. So I can put the 3 to the exponent there. This is going to be log of x cubed. And then the 1/2 goes over there to the exponent y. So it's going to be log of y to the 1/2 minus 2. The 2 I'm going to put up there to the exponent as an exponent for z, log of z. Okay, so that one step down. Now, what we can do, because these two are being added, we said that we can combine these two by multiplying x cubed and y to the 1/2. So this one could be log of x cubed times y to the 1/2 minus log of, I forgot the 2, z squared. Z squared. Okay, so that's one part. Now, because this is subtracting, I can rewrite that as log of x cubed y to the 1/2. Because it's subtracted, so it's going to be divided by z squared. Okay, so these ones is applying the laws of logarithm to break it down to just one logarithm expression. Now let's take a look at letter B. 4 plus log base 2 of 3. Okay, now how do we go about this one here? How can we do this? Apply the logarithm rules in here. This one is log, and then this is just 4. Let's take a look. If we were to do a base 2, okay, log of base 2 will, the exponent is 4. 2 2 exponent 4 will give me 16. Okay, so this one here, we can rewrite that as a logarithm with base 2, because b, the what exponent 4 will give me 16 plus log 2 of 3. Now these two are added together, so that means log of base 2 times 16 times 3. So that means log base 2 of 48. Okay, so that one is a challenging one, right? Because we have to figure out the logarithm of 16 base 2 out of the 4 there. Okay, now let's take a look at number 13. If you have any questions, feel free to type this in. I'm just going over as much questions as possible, so there's some kind of an explanation for you. Now we're going to do evaluate. Now the word evaluate means what is the value? What is the value of this information that they give? They gave us 2 log base 4 of 6 minus log base 4 of 18 plus log base 4 of 8. Now this particular case, they're saying is, what do I need? What kind of exponent do I need for 4 to get 6? That's one's going to be a little bit challenging, because 4 to what exponent give me 6 is not going to be a nice number. Same thing with 18. Same thing with 8. So what we're going to do, let's see if we can simplify this. So bringing the 2 to the, so log of base 4 of 6 squared minus log base 4 of 18 plus log base 4 of 8. Let's see if we can simplify all these stuff. So this is where we could probably combine it as one single logarithm and then figuring it out. So log base 4 of 36 minus log base 4 of 18 plus log base 4 of 8. These two are being subtracted, so that means 36 has to be divided by 18. Log 36 divided by 18. And then all of that is being added by log base 4 of 8. So because of this is being added, that means it's timesing it by 8, multiplying by 8. Okay. So 36 and 18 cancel each other out. So that becomes 2. And then 2 times 8 is 16. So this really breaks it down to 2 log base 2 of 16. Log base 4 of 16. So the answer there is 2. So 4 to what exponent to get me 16? That's 4 squared. It's 2. So the answer is nice number 2. Okay, so evaluate means not solving, but going down to figuring out its value. I'll do number 14 here. Approximated each logarithm. So number 14, we're supposed to go logarithm base 5 of 600. Now, what exponent do I need to apply to 5 to get a 600? Well, that's going to be challenging to kind of do a trial and error thing. So what we're going to do is we're going to use the change of base approach. So it's going to be log of 600 divided by log of 5. So log of 600 divided by log of 5. And then, of course, you can do that on your calculator. It's going to be 3.97. So approximately equal to 3.97. Oh, they said nearest thousand, so the 3.975. Okay, so this one we have to do the change of base approach. And then for letter B, it's going to be log base 3 of 0.1. Okay, so we're not going to do trial and error in here. What we're going to do is we're going to do a change of base. So log of 0.1 divided by the log of the base 3. So log of 3. So log of 0.1 divided by log of 3. And I got a negative 2.096 approximately. Okay, so that's a change of base. Okay, so we did quite a bit of stuff in here. We have about 10 more minutes. I'm gonna, if there's something that you want me to take a look at, and then let me know. I'm probably gonna do I'm gonna do 17. Let's jump to number 17. If you have any particular question that you want me to take a look at, just send, and if you're watching in the live chat now, you can send me a live chat question. So it says here, I'm gonna just jump right down to 17. Okay, this one is solving logarithm. Logarithm equation. So 3 log base 2 of x plus 5 plus log base 2 of x plus 7. So what are we going to do here? We have x plus 5 and then x plus 7. So how can we go about this one? Let's see if we could use some of the properties of logarithm or laws of logarithm, because these two are being added, right? Two logarithms being added. We can simplify that as log base 2 of x plus 5 times x plus 7. So this is where combining it as a single logarithm is important. Now that we have that, we can change the logarithm equation to a exponential equation. So that means 2 to the exponent 3, 2 cubed. What is that equal to? X plus 5 times x plus 7. And then this is a nice quadratic equation. Okay, and we know how to do this. So 2 cubed, that's 8. X plus 5 times x plus 7. We can expand this one. Let's see. X squared plus, if I expand, that's going to give us 12x plus 35. And then bring this to the other side of the equation. X squared plus 12x 35 minus 27. Minus 27. Okay, so is this even factorable? That's going to give us negative 27. So that's going to give us positive 9 and negative 3. So these are the two numbers. So therefore x equals to negative 9 and then x equals to 3. So now we have to look over here, go back up, and if we put in the values there, look for extraneous solution. So if I put in negative 9 here and negative 9 there, we're going to end up with a negative value here. So 2 to what exponent will give me this number? There's no solution. So x equals to negative 9 is not a solution. This is an extraneous solution. Now if I put the 3 there, 3 plus 5, that's going to give us 8. And then 3 plus 7, that's going to give us 10. That's gonna work out for us. Okay. So I'm just going to go take a look at, yeah, we got a little bit of time. Take a look at B. I just want to say this is the only solution. Take a look at letter B. Log of x plus log of x plus 1 equals to log of 7x minus 8. Okay, well these two, because this is the sum of the logarithms, log of x plus 1, we can combine it as a single logarithm. So that becomes log of x times x plus 1 equals to log of 7x minus 8. Now they're both logarithm on each side of the equation. So, and they're both log base 10. So if they're the same log base 10, that means x times x plus 1 and 7 times x minus 8 must be equal to each other. So therefore, x times x plus 1 equals to 7x minus 8. So expand this one. And again, we're gonna get a quadratic equation in here. So bring everything on one side of the equation. So x squared, that's going to give us negative 6x plus 8 equals to 0. So this is going to be x minus 4 and 2, right? So we have two solutions, or at least we think we have two solutions. Okay, so it's either 4 or 2 or 4. Now let's see here. Now this one here, if you put a 4, so that's a positive. That's a positive, so that's okay. If I put a 4 there, that's a positive. Okay, so that works. If I put a 2, that's a positive. That's a positive, and that's also a positive. So they're both solutions. Okay, so okay, that's number 17. I probably have time to squeeze a number 18. Like I said, I'm trying to do as much as I can, show you all the solutions. So this is number 18a. Solve the following. Okay, so this one here is an exponential equation. So divide both sides by 5. 5 cancels. So now we're left with 3 to the x equals to 12. Okay, now we're going to get into this solution where 3 to the x is equals to 12. Since we're looking for the exponent, so we have to do logarithm. Take the logarithm of both sides of the equation and then apply the logarithm rule. So this x exponent will now move over here to front. So x times log 3 equals to log 12. And then finally divide by log 3 on both sides of the equations. Okay, so log of 12 divided by the log of 3. It's probably not a nice number. Okay, I got 2.26. 2.26. Here you go. So that means that this exponent x is 2.26. Okay, let's do the last one, 18b. Okay, we have an issue here because now we get two exponential expression on each side of the equation. So like 3 to the x plus 4 is equals to 5 to the x plus 1. What we're solving for is in the exponent. So what we have to do is we need to do the logarithm of each side. So take the log of 3 to the exponent x plus 4, log of 5 to the x plus 1. From here, we're going to have the x plus 1, use the logarithm rules, bring it to the front. Same thing with x plus 4, logarithm rules, bring it to the front. So it becomes x plus 4. I have to remember to put it in the brackets because it's a binomial up there. Log 3, and this is x plus 1, log 5. And we have to do the distributive property of multiplication. So it's x log 3 plus 4 log 3. And then same thing with this side. X log 5 plus 1 log 5, which is log of 5. Okay, so now I see that there's x's on both sides of the equation. So we're going to put the terms that has an x variable on one side of the equation and the ones that just plain numbers on the other side. X log 3 minus x log 5 equals to log 5 minus 4 log 3. I'm sorry, I'm going over here, over time. Factor out the x. So if I factor out the x, I'm going to get log 3 minus log 5. And then you go, I can do this part here. Log 5 minus, and I'm going to bring this 4 up there. Log 3 to the 4. Okay, so both. We can simplify this one here. So we can say log 3 minus log of 5. We can simplify it as log of 3 divided by 5. And then this one here, we could also simplify this as single logarithm, log of 5 over 3 to the 4th, which is 81. Okay, so that's that. And then finally, divide by the log of 3 over 5, log of 3 over 5. So x is equals to 5 divided by 81 divided by log of 3 divided by 5. And I got 5.452, approximately 5.542. Okay, so there we have it. I'm sorry it took way too long, but I tried to go as much examples, as much solutions as possible. So I hope that that will help you study and get you ready for tomorrow's test. I will post your test tomorrow on the blog, and I'll have it there. Um, okay, but for today, you can continue working on some of the questions that you have. Um, go over it all over again, and if you have any questions, you can send me an email, and then we'll go from there. Hopefully, I can answer some of your questions. Okay, thank you very much for watching, and yeah, keep in touch and let me know if there's anything else I can help you with. Okay, so have a great day, and talk to you later. Okay, bye.